Continuing on with section 1.2, we're going to talk about some properties of real numbers. One thing to note before we look at some of those properties, it says one property of real numbers excludes a single number, 0. 0 is the additive identity for the real numbers, and 0 is the one real number that has no multiplicative inverse. So an opposite or an additive identity of any number a is negative a, or the opposite of a. It says the sum of a number and its opposite is 0, which is the additive identity. It talks about a reciprocal or multiplicative inverse. It says of any non-zero number, a is 1 over a. Inverse to me kind of sounds a little like reverse, which in this case you're flipping it. You're taking the reciprocal of it. It says the product of a number and its reciprocal is 1, which is the multiplicative identity. Understanding additive identity and multiplicative identity will show up in this next chart. So some properties of real numbers, some of these you would have known from previous classes if you took Algebra 1 last year. Maybe you took geometry prior to taking Algebra 2. You would see some of these in some of those other courses as well. So the first property they talk about is closure. In addition, it has a plus b is a real number. Closure meaning if you add a real number with a real number, you get a real number. For multiplication, ab or a times b is a real number. If you take a real number and multiply it by a real number, you end up with a real number. That's the closure. Closure meaning you can't get out of being a real number. It doesn't become some other sort of type of number. The commutative property, it has a plus b equals b plus a. Commutative, I think of kind of like communicating. You're taking turns. All you're doing is you're taking a and b and you're flip-flopping the order of them. Same thing with the multiplication. If you have an AB, that's equal to BA. Hopefully by now you understand it doesn't matter the order that you add or multiply in, you end up with the same value. The associative property has grouped together A plus B and then add C, and that's equal to A plus B plus C. The order of the A, B, and C does not matter. What matters is what's moving or changing. The parentheses are changing. So you're associating A with B, and then B says, I'm done with A, I'm going to now associate with C. Kind of like when you're sitting in class. You work with the person on your left, you're associating with them, and then you have to turn and talk to the person on your right. So now you're associating with them. It's kind of like your parentheses are moving by who you are associating with, but you haven't gotten out of your seat. You're still in that same order. It's just the groupings change. Same thing with multiplication. So you still have order A, B, C. It's who's being grouped together that is being shown with the associative property. The next one talks about an identity. Now that's where those additive identity, that definition, and the multiplicative identity, those definitions came in. It says A plus 0 is equal to A, or 0 plus A is equal to A. 0 is the additive identity. Identity, you're starting with a number. What can you add to it to not change the identity of that number? Well, you can add 0. Same thing with multiplication. They have an A times 1 is equal to A, or 1 times A is equal to A. It says 1 is the multiplicative identity. Well, if I start with a number, what can I multiply with it that's not going to change the identity of that number? I can multiply by 1 and not change the identity of that number. The next one talks about an inverse. So it has A plus the opposite of A is equal to 0. That's where they're getting into some of those additive inverses back in the definitions at the top. So if I'm starting with A, my goal is to get back to that identity number, which is 0. So if I start with A, I can add the opposite of A to get back to 0. Inverse to me sounds like reverse. You're undoing it. And then if we have, sorry, it's a little blurry, they have A times the reciprocal 1 over A is equal to 1. Excuse me. And they also mention that A cannot be equal to 0. We cannot divide by 0. And the last one talks about the distributive property. And that's something kind of nice and easy that you guys remember, right? Take what's on the outside and multiply it in. Let's look at a couple examples. Example 4. It says, what property is illustrated by each of the following equations? So let's see, we have an xyz equals xzy. Are they all in the same order? No. Let's see. We start with x, we start with x. We have a yz, but then we have a zy. What operation is going on? Well, we have multiplication. And if we flip-flop the order, that means we have the commutative property of multiplication. If I look at part B, I have F, G, H, F, G, H. What's changing? Grouping symbols are changing. Who G is associating with is what's changing. So we're going to have the associative property. If you're going to abbreviate associative property, make sure you use more than the first three letters. So the associative property, and we are multiplying. If we look at C, we got some parentheses, but P plus Q is grouped, and Q plus P is grouped. So who you're associating with doesn't change. It's still P and Q in the same set of parentheses. R is still on the outside, but what happened? We went from a P plus Q to a Q plus P. We're flip-flopping those terms. What's that one? That's going to be the commutative property. And the operation going on between those two terms is an addition. If I look at part D, we have a 5 plus y times x and an x times 5 plus y. Well, it looks like the x was on the back side, now the x is on the front side. The 5 plus y doesn't change. That means we're flip-flopping our terms. And if we're flip-flopping terms, that means we are doing a commutative property. And we have multiplication because x is being multiplied with those parentheses. Part E, we have an 8 plus 0 is equal to a 0 plus 8. Again, flip-flopping. Got a lot of commutative examples, huh? And F, we have a v plus 0 plus w equals a v plus w. So this 0 ended up going away. We are doing some sort of addition. So if I add 0 to something, that means that we are dealing with an identity property of addition.